Okay, so we're looking at housing construction here. In this video, we're looking at something called pouring the footings. Footings are made of concrete, so we're pouring concrete into something called the footings. Now, what are footings? Now, if you've got, this is a simple rectangular house, let's say. Now, obviously, you're going to have walls around the outside of the house. And those walls have to hold up a lot of weight. Those exterior walls hold up the weight of the roof. Things you don't want those walls, I guess, sinking into the ground. So what happens is around the outside of the concrete slab that a house sits on, we pour deeper foundations. Those deeper foundations are called footings. So this stuff that I'm colouring in red here is called footings, and that bit's going to be much deeper. That concrete's going to be poured much deeper than the rest of the slab. So that basically is what we talk about when we're talking about footings. Now let's take a look at the house in question. It says a house with a rectangular floor plan measuring 18,000. Now, if there's no units there, it's always in millimeters. 18,000 millimeters by 12,000 millimeters has footings 350 millimeters wide and 450 millimeters deep dug around its perimeter. We need to know what volume of concrete would the footings require, first of all, and then we need to know what the cost of it would be if it was in meters cubed. First of all, I'm just going to draw this. Now again, I might just get rid of that one first. Okay, so basically I'm going to redraw that, what was just there. Now it's a house with a rectangular flooring plan that's 18,000 by 12,000. So there's my rectangular floor plan. Now the long side is 18,000 millimeters. Now if you need to convert millimeters to meters, which is a good idea in questions like this, you just need to divide by 1,000. So that's going to be 18 meters wide by 18 meters long by 12 meters wide. Now it has footings of 350 millimeters wide. So the footings are these things that go all the way around that hold up the exterior walls. And that width from there to there, so from the inside to the outside, all the way around, I know it hasn't been particularly neat, that width from there to there is 350 millimeters. Now to convert 350 millimeters to meters, because everything needs to be in the same units, again we divide it by 1,000 and we'll get 0.350. That's the width of that. That's the width of there. Okay, and now that's our top-down view. Now, how deep do these footings go? How deep do these footings go into the ground? They go 450 millimeters deep into the ground. Okay, so everything goes down 450 millimeters. Okay, that's the easiest way to think of it. It's a rectangular prism. Now that dimension there is 450 millimeters, which is 0.450 meters. So you should start to see that this is a prism, which is what we learnt about last term. So we shouldn't have too much trouble. We need to find the area. We need to find the volume of this exterior bit here. Now, just in case you've had some difficulty deciphering my diagram, here's a diagram that I've stolen from the book that gives you the same information. Okay, so it's really just down to finding the volume of this, and we do that by finding first the area of this cross section. You should remember that, and then multiplying it by the depth. Now, finding the area of that cross section is going to take a little bit of work. The area of the cross section for this particular question is going to be equal to the area of the big rectangle, so the rectangle on the outside, so area of big rectangle minus the area of the small rectangle. And the small rectangle is this one on the inside. Now the dimensions of the big rectangle, that's pretty straightforward. It's this 12 meters by this 18 meters. So 12 times 18. Now the smaller rectangle is a little more complicated. The smaller rectangle's width is 12 minus the 0.35 times 2, because there's 2 of those. So minus, now the length here is going to be 12 minus 0.35, because there's 0.35 on this side, minus 0.35, because there's 0.35 on this side. Now if you type that into your calculator, you should end up getting something like 11.3. So the length of that is 11.3. Now you can do the same here for this length. That's going to be 18 minus the 0.35 on this side minus the 0.35 on this side. And that's going to give you 17.3. So the area of the big rectangle is 12 times 18, which is 216. The area of the small rectangle is 11.3 times 17.3, which is 195.49, which means that when you subtract one from the other, you should get 20.51 meters squared. That means that this shaded red bit here, this area around this bit, just around the outside, which is where our footings is 20.5 meters squared. Now the volume will be equal to that area times the depth, which is 0.45. So it's going to be the area of the cross section, which we just figured out, times the height or the depth of the footings. That's going to be equal to 20.5 times 0.45. Okay, you type that into your calculator and you'll get 9.2295 meters cubed. Okay, we'll just round that up and we end up with 9.3 meters cubed. So we need 9.3 meters cubed of concrete to pour the footings into our house, to pour these foundations. So that's the answer to part A. Now part B is much, much simpler. What would be the cost of this concrete at 150 meters cubed? Now cost is equal to number required times cost per unit, or cost per thing. So the number required, we need 9.3 meters cubed. We need 9.3, and we need to multiply that by, each meter cubed is 150. So that means that 9.3 times 150. Okay, so you type that into your calculator and you'll get $1,394.43. So that's how much it's going to cost to pour our footings for this particular house. That's the foundations required. After that, a slab's poured on top for your floor, a concrete slab to put on your floor, but we'll do that in another video.